So I know quite a few of you have actually asked about proactive bots and how bots can initiate conversations. Well, not initiate, but kind of send messages in a long-running process or something. So that's what we're going to dig into today. I've tried to strip back as much of the technical detail away, that you don't necessarily care about, and really just get the core concepts down for you. So again, code's available here. It's pretty straightforward. After this, I encourage you to have a play around with your own particular scenario. Just make sure you're comfortable, the way it works. So up until this point, really, we've been talking about quite an imperative conversation style. So as a user, I might say something to a bot, and the bot might respond instantly. It might take a few seconds to respond, but usually it's in the same thread, right? It's in the same process, but it isn't always like that, So I've got some examples here. Reminders and alerts. This one's a really good one. So, airline, there's a delay in your flight. You're obviously not going to send a message to the airline every 5 minutes to check whether the flight's delayed. That's a really good example where the airline would want to send a message to you. Long-running tasks. In this example, we've got a build, which obviously can take minutes, if not hours. So that can happen in the background. When it's done, it can use proactive notification to continue that conversation. And then things like cross-selling and upselling products. So, maybe you've ordered some trousers and you want to sell some shoes to someone. You can use the information you already have about them, including the channel information to route that message back. And then finally, this is probably the most common scenario. Actually, this is a human in the loop, because a bot's not going to deliver 100% of your requirements, right? It's just not. So being aware of how you can accommodate human in the loop is key, and this is one technique that you can use to kind of make this work. So to illustrate this process, I've really tried to kind of visualize this as best I can. Hopefully it's clear, but if it's not, please shout out. So we've got a user here. The user is asking a question, right? So in normal situations, the bot can go off to a machine service, right? And pretty much instantly get a response. Okay, but maybe we've got some kind of process, like let's say a long-running task, or maybe someone's complaining about a problem which needs investigation by a human. Okay, so a user complains, the bot talks to the service, it realizes it actually can't deliver that. So it saves information about the conversation inside this thing called, it used to be called a resumption cookie. That's why it's a cookie. It's not a resumption cookie anymore, okay? But basically it's got all the information that you need to resume a conversation inside that piece of data. Okay, now the human might have some kind of long-running process that it needs to carry out. Maybe it needs to investigate, maybe it needs to do some work of its own. Once it's finished, it uses the information inside this cookie to route the message back through the bot to the user. And from the user's point of view, it's a consistent user experience, even though the information and the process is being delivered by a different participant, right? So to kind of illustrate this, I've got a demo. As I say, it's quite straightforward, so hopefully it shouldn't take too long to explain. And inside here, we've got our messages controller. So this is our bot application, right? Which you guys should be familiar with. So inside here, what I'm doing is I'm always basically saying I don't know how to deal with it. So this is the world's most useless customer support bot. It basically never knows the answer. So it's always saying I don't know how to deal with that. Gives that back to the user as a response. And then it saves the reference to the conversation. Okay, it saves that onto disk. Here I'm just literally just saving it out to file. But obviously, if you're using, database as your table storage, whatever, that'd be you'd use that persistence mechanism to store that information. Inside that information, you have well, you can see you've got the ID of the activity, you've got who the activity is from, who the recipient is, the conversation information, the channel ID, so which channel it's come from, and then the service URL, and that's basically how we get the message back to the user, right? So all that information gets saved, in this case to disk, but in your case it's probably going to be a database or something. So I'll just show you what that looks like briefly. So this is basically, I'm going to zoom in. I can't zoom in. Hopefully you can see that. So we've got our activity ID, then we've got user, we've got the bot information, information about the conversation, and then which channel and how we route the message back to the user. Okay, I'm going to demonstrate this in the emulator, but this works for any channel, as long as the channel accepts notifications. Okay. So once we're done with that, we send back a HTTP 200, as you guys are already doing, and then the conversation kind of suspends from the user's point of view, and they're just waiting for a response. Okay. Now, in order to simulate the back-end human process, what I've got is I've got a callback controller. So this is completely separate to the bot, okay? It happens to be a web API controller, but this could be anything. It could be Windows Service. It's just something that's basically running a background job and is basically talking back to the bot, right? So here, when we get the proactive message, we load that conversation information from disk. And that's the information we need to resume the conversation. Okay, we deserialize that into a conversation reference. We then create a connector client with the information that we've already got in that conversation reference. And we use this resume data to create ourselves a reply, which will get routed back to the right place. Okay, we then just send it back as any other as any other message would be. Does that make sense to everyone before I demo it? Yeah, so we've got two web API controllers. One is the BOSS application, which you've all been using. The other one is a web API controller to simulate a human process. And I'm just going to invoke that using curl when I'm done. Okay? So I'm just going to run this now. In fact, it's already running. So I'm just going to, I'm going to report a problem with a website. So this is a support bot. With your website, it is returning a server error. Okay. So the bot's come back, it instantly said it doesn't know how to deal with that, so it's passed it on to a human. Okay. So as a user, now I can kind of get on with my day. I don't need to worry about continuing the conversation. But as an organization who's providing the service, I obviously have some work to do to sort this out. Now, once I've sorted it out, I've got some kind of process that's going to send a message back to my second web API controller to basically route the message back to the bot. That makes sense? So to do that, I'm just going to issue a curl HTTP post with this JSON payload and just saying the problem has been fixed. So imagine this is, you've got some portal, support portal, maybe it's Zendesk or something that you're using to manage your support process. And all that's doing is posting back to this API controller. So just run that, that's it. And you can see the message has been returned back to the conversation in context. And this works with any channel. If you're using Facebook Messengers or Teams or whatever you're using, as long as the channel supports notifications, you'll be able to use this. Okay, so I'll just jump back to the slides. As I say, code is available there. It's really straightforward. There's probably, 20 lines of code for you there. I've really tried to peel back all the complexity. So, have a look, and if you've got any questions, shout out. That's it. Hopefully that was useful. Good. Not that I'm aware of. I guess it might depend on the channel that you're using, but I haven't seen that information would need to be in the token. So it's pretty easy to inspect whether it's got a lifetime or not. I don't think it does, because I know companies are using it to kind of sell products that months after the message has come in. Yes. It's a good point, actually, and this has been built so you don't abuse it. Basically, you can't just spam people unsolicited. They have to engage with your bot first before you even have the information you can use to route the message back. Yeah. Yes. So was the question, can you have channel-specific rules? Yeah, by all means. I mean, you'd have to write those rules, but yeah, there's no reason why not. Because you have that information in the cookie. It tells you what, sorry, I'll stop calling it cookie, the conversation token. But it has the channel information in there, so you could see in this one, we have the emulator, right? So if you're using Facebook, that's Facebook. If it's Skype, it's Skype. So you just have to make a decision off the back of that. In this scenario, you'd have to manage that process. So there are some tools and techniques you can use. There's something called iScorable, which allows you to kind of prioritize these dialogues. So certain dialogues take precedence of others. But because we've kind of stripped all that back, you literally would have to handle that yourself. Yeah. Yeah. Right. So it depends whether you're using the web chat or whether you're using direct line, because direct line does support this, but web chat doesn't, as far as I know. Yeah, well, I mean, we'll check, but as far as I know, the only way you could do it is to use a direct line and control it. Yeah. Yes, you're not restricted in terms of what you can delete. You've basically got the same capabilities as you would, a normal conversation. Yes. Yeah, yeah. So you could use it to opt out. Yeah, that's really good. Good example. Yeah. Lovely. Cheers, guys.